Alright, we're going to talk about congruent figures today. So congruent polygons, and in particular we're focusing on triangles, are two polygons are congruent if and only if they are the exact same size or shape. Okay, so that is key right there. They have to be the exact same size and the exact same shape. Or we could say corresponding parts are congruent. So the parts of a triangle we say is made up of 3 sides and 3 angles. Okay, so if you have 2 triangles that are congruent, that means all 3 sides would match up, all 3 angles would match up in a particular order as well. So here is one example. So we have these 2 triangles. We see that they are congruent. There's these markings on them. So from B to A we have this little dash, and from D to E we have the same dash, meaning that we'd write it this way. We'd write AB, the segment, is congruent, this is the symbol for congruent, to ED, the segment. So those 2 segments would match. Also we could say that AC, that segment would be congruent. See how it's got 2 hash marks on it, and you look at the other picture, see where there's 2 hash marks, and that would be DF. And then there's one more set of corresponding sides. BC in the top triangle is going to be congruent to EF, and I know that because they each have 3 hash marks on them. Now if you wanted to, you could, BC, you could write BC, or you could write CB. CB and BC would be the same thing. It's the same segment. So it doesn't matter the order in which you write the segment. I just kept it alphabetical in this case. Actually not all the way, because ED would not be alphabetical. So just know with segments you could switch it around. So CB and BC would be the same. For angles, we're going to say, well, angle A is congruent, and angle A has 3 kind of semi or arcs, right, on it, and angle D has 3 arcs on it, so those are congruent. Angle E is congruent to angle B because they both have 2 arcs, and angle C is congruent to angle F because they have 2 arcs. So we have 3 congruent pairs for sides and 3 congruent pairs for angles, and these triangles match up in a particular way to say that they're congruent. So we want to say that triangles are congruent. Now when you name a triangle, you name it by its, so you're going to say triangle, and you name it by its 3 vertices. So we could say ABC, or we could also say well, triangle ABC, triangle could be BAC, could be triangle BCA, triangle CAB. There's just different ways to name the same triangle, and I'm just trying to go through all the different ways here. So there's 6 different ways. All these refer to the same triangle. So when you're naming your triangle, you can pick one of those 6. It doesn't matter which one. But once you pick one of those 6, it's going to matter how you relate it to the next triangle. So if I choose ABC, then I have to, the order really does matter for this next one. A corresponds to D, so D has to be my first letter. B is the second letter in ABC, so B is corresponding to E, so I have to use E second. And then C corresponds to F, so I have to go F. If I did something like triangle CBA, then so you have the freedom of how you name the first triangle, but then the second triangle is dependent upon that first. So you would have to name the second one triangle FED. Okay. So that's a little bit about what congruence is and how to write some of that notation. So then this next problem says, if triangle WYS is congruent to MKV. So they're already telling you they are congruent, and based on that congruent statement, name all the congruent parts. So you can do this without even drawing a picture. I know that angle W is going to be congruent to angle M because they are both the first letter in the way it's written. So that's why it's important that there's a correspondence in how that's written. We know that angle Y is going to be congruent to angle K because they're both the second letter in those statements. And angle S is congruent to angle V. If you need to draw a picture, you can say, well, or at least draw one of them, right? You can say here's WYS, and you can think, well, what are the sides of that? I got WY is one side, YS is another side, and SW is a third side. But once you kind of know what your 3 sides are of one triangle, you can go back and look at the correspondence statement to write the second side. So WY are the first 2 letters of the statement, so they're going to match the first 2 letters of the second statement. So that would go with MK. You can also write KM because the order doesn't matter on the segment. MK, KM are the same. YS are the last 2 letters, so that would go with KV. And SW, that's the last and the first, would go with V and M. Next problem. Given that triangle STW is congruent to BFN. So we know the 2 triangles are congruent. Find the missing values. Okay. Now, notice the notation here is different. BN does not have a line across from the top. So if I do this, BN with a little segment above, that's talking about the segment itself. But if I go BN without the top, that's talking about the length of the segment. Also, if I do like angle W, that refers to the actual angle W. But if I go M angle W, that's talking about the measure of the angle. Okay. So slight differences in notation here, but they're important differences to note. So we're going to see that here. So Bn, we don't know what that is. We know Fn is 14, but that's not given. We know that Bn, the segment, is congruent to SW because B and N are the first and the last letters of that statement, and so S and W are the first and last statements of or letters of the first statement. And if I look at SW, so this is equal to SW, which is 9. And I could write that in, so Bn is 9 in my picture. TW, well, we know that the segment TW is congruent to the segment Fn. So the length of TW is going to be equal, not congruent, equals. Notice that it changes to equal here. Fn. Fn is 14. So I'm going to jot that down, that TW is 14. And then BF is going to be the same as ST, and ST is 17. So we're talking about the lengths of the segments, so the answers are numbers. We're using an equal sign instead of a congruent sign. The measure of angle W is going to equal the measure of angle what? So W is the last letter, so N. And we know the measure of angle N, which is 82 degrees. The measure of angle B is going to equal the measure of angle S, because they're both the first letters in my congruent statement. And so S is 67, so 67 degrees. So I'm going to write that in there. We got 67 degrees, and we have an 82 degrees at W. And the measure of angle F we can find in a triangle. Here's something we should know from prior, and I'm just going to jot it down. But all three interior angles in any triangle must add up to, do you guys remember? 180 degrees. So in triangle BFN we have two angles, 67 and 82, and so let's call this X, what we're trying to find. I'll put the X there for angle F, and we know that X, if I add them up, X plus 67 plus 82 is going to equal 180 degrees. And so we have a little equation to solve. I'm going to add 67 and 82, and we're going to get 149. So we got X plus 149 is equal to 180. Subtract 149 from both sides, and we're going to get X is equal to 31, and we're talking degrees here. And there you go. So the next page is going to be part of your homework, and mostly it's what we've been doing. So you have name all the congruent parts, name all the congruent parts. That's just like what we did in this problem here. Okay. Then you have name three congruent triangle pairs, and so remember, like if I start with the top triangle, I can name it differently. I can name it TWP. I can name it TPW. I can name it WPT. There's actually 6 different ways to name that first triangle. But once you name that first triangle, then it matters how you name the second triangle, right? It has to correspond. This last one here is a little different, so I will help you out with this, okay? It's asking us to find the value of x, y, and z, and we know that UV and TS are congruent, so I could write that. So UV is congruent to TS because the triangles are congruent, and if the triangles are congruent, then the corresponding parts are congruent, right? Now because they're congruent, we can say that UV, the length of UV, is equal, not congruent, but equal to TS. So UV is 12x minus 7. TS is 53. And now I have a little equation to solve for x. I'll add 7 to both sides. I get 12x is equal to 60. Divide both sides by 12, and I get x is 5. So I want you to finish this for homework and go ahead and find out what y is and find out what z is. And then down here, this last one on this page is going to be like the last one on the first page that I did with you. So I want you guys to try that out on your own. That will be part of your homework. Okay, now let's talk about different ways to establish if triangles are congruent. So by definition, if you want to use the definition of congruent triangles, you're going to have to show that all 6 parts are congruent, right? Remember, triangles have 6 parts. They have 3 sides and they have 3 angles. But the question is there a shortcut? And there is. Okay, so and these are the shortcuts. So in this first picture, if you're able to show that just 3 sides correspond to 3 sides in a triangle, which we call SSS for side, 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 if you're able to show that, then that's enough to say that the 2 triangles are congruent, which would mean all the angles are also congruent. All 6 parts are congruent to all 6 parts. So it's a shortcut, and it's one that I want you to know. So side, side, side is one way to establish that the 2 triangles perfectly match, or they're congruent. Another shortcut is side, angle, side, abbreviated SAS. Notice in how we write SAS that the A is squeezed in between the 2 sides. That's what has to happen in your picture, right? If you notice the 2 sides, we got these 2 sides corresponding, right, because they have 1 tick mark. We have these 2 sides corresponding, and those 2 sides form an angle. That angle has to be the angle that you do know. So it has to be this particular angle. If it was a different angle, it would not be side, angle, side, because the angle would not be right in between those 2 sides, and then it wouldn't be congruent. So this is where it's important that you note the order that things happen in. So here we have the angle that happens between the 2 sides, and because of that we call it side, angle, side, and it's another shortcut for establishing congruence. Just a side note here, so if I had something like this, okay, this would not be side, side, angle, side. This would be considered side, side, angle, right? Because that's the order in which things happen here. And this does not work. Okay, so side angle does not work for establishing congruence. That's going to be important to note. Right, another shortcut, angle side angle. Again, notice that the S is between the two A's, and you find your two angles, and it's the side in between the two angles. Versus the next one, which is angle side, where the side is not in between the two angles, and you see your two angles in the picture, the side not in between the two angles. There's two options. Both of those work. Okay, again, two more shortcuts. And then the last shortcut, now if we think about angles and sides, this would be side angle, like up here where I said it didn't work. In general that doesn't work, but there's a special case where it works, and that's if your angle's a right angle. Because if you have a right angle, you have a right triangle. Remember the longest side in a right triangle is what we call the hypotenuse. It's the side always across from the 90-degree angle. And then the other two sides we call legs. So there's two legs and one hypotenuse. So if you have a right triangle, so meaning you have a 90-degree angle, and you have a leg congruent to a leg, and a hypotenuse congruent to hypotenuse, doesn't matter which leg, right? Then we say they're congruent by HL, which is hypotenuse leg. Okay, so to summarize this, I'm gonna summarize this over in the left-hand side. Okay, so our shortcuts, we got 5 of them. We have side angle side, angle side angle, angle side, and hypotenuse leg. Those are the only 5 shortcuts that work. Memorize them. The ones that do not work would be side angle, or you could reverse that and spell donkey. Okay, angle side. I'm not going to write that out though. Or angle. Okay, those do not work, and you want to memorize that too. Okay, so let's try this out. So in this first picture here, we have, if you just look at one triangle, you have a side, another side here, and an angle in between. So that would follow the pattern side angle side. But you got to make sure it corresponds, and it does. We got 2 hash marks, we got 1 hash mark, and the 65 in between. So this would be side angle side. Okay, that's the type of triangle congruence. And then we need a congruent statement. So a congruent statement would be something like this: triangle UZL is congruent to triangle. Remember, you can name the first one however you wish, but once you name the first one, you have to be careful how you name the second one. So U is at the end of the double dash, not on the 65, right? So double dash, so that would go with D. Okay, Z is on the single dash, not with the 65, so that would be A. And L is where the 65 is, so that would be I. Okay, so we have our type of congruence and we have our congruent statement. We have to put both of those on here. Now on the second one, we only have 2 parts, and we need 3 parts unless it's hypotenuse leg, and we don't have a right triangle here. But there's something that you need to remember. If you have 2 segments that make an X, they form what we call vertical angles, and vertical angles are congruent. So we're going to jot that down here. Vertical angles are congruent. Okay, and Notice if I said angle M, you wouldn't know exactly which angle I'm talking about because there's a lot going on at point M. There's actually 4 angles that happen at that spot. So if you have something with some ambiguity, you're going to have to use 3 letters to talk about that angle. So for example, where I'm pointing with an arrow here, that angle would be called angle AMD, because if I traced from A to M to D, it would form that particular angle. And then the other angle that it's congruent to would be angle RMC. Or you could say angle CMR, right? Because there's 2 ways to draw that. You could start at R and end at C, or you could start at C and end at R. Also, on the first one, we started at A, ended with D. You could also start with D and end with A, right? So both, there's 2 ways to write an angle with 3 letters. What's most important though is where that is happening at M. That M has to be the middle letter because of how it's drawn. So with that said, the first triangle is congruent to the second one because we have angle, side, angle, congruent to angle, side, angle. So angle, side, angle is what we're working with here. So that's the type of congruence. And then the triangle congruence statement, we'd say triangle ADM. Okay, so I picked an order for the triangle, and here's where really you got to be picky. It matters. So A has the 1 arc, R has the 1 arc, so R goes first. D's second, that's the angle without anything, so that matches up with C. And then M goes with M, right? Alright, this next statement here, notice we got 2 triangles that share a side. Okay, so FD is in 2 triangles, and it makes sense that FD is congruent to itself. And I don't know if there's a property that says things are congruent to themselves, and it's called the reflexive property. We're going to have to learn that. So I'll bring it up now. But we have a shared side, and so we can go ahead and do this, that FD is congruent to itself. So in one triangle you have side, side, side. In the other triangle you have side, side, side. So the triangles are congruent by side, side, side. Okay. And which triangle? Well, triangle ADF would be congruent to triangle, and you work through it, E would correspond with A, because A is between the 1 and the 2 dash, so is E. D, and then F. Okay, so this next one, just the way it's written, you see side, side, side. So we could say triangle GTI is congruent to triangle G is between the 1 and the 2, and so is A. T is between the 1 and the 3 marks, so is N, and then I. By side, side, side. If we wanted to, we could say we got vertical angles here. So then you can also say it's by side angle side. You can't say side side angle because that one doesn't work. So those would be our options. This next one, we could say that triangle GAI is congruent to triangle SAI by what? Well, we have this shared side. AI is congruent to AI. Sorry, I'm thinking I, so I'm drawing an I and mixing that with congruence. Okay, so AI is congruent to AI. Remember that it's called the reflexive property that allows us to do that. And so here we have side side angle, but side side angle doesn't work. But there's that special case. Keep an eye out. If you have a right triangle, right, you have your hypotenuse here and you have your leg here, and so hypotenuse leg would be our reasoning for why they're congruent. So this last one on the page, here's some notation. This, if you have two lines that don't cross right here, this is referring to parallel. Okay, so we're given that OH is parallel to AT. When you draw parallel, you usually use like little arrows. So OH, so there's an arrow, is parallel to AT. That does not mean that they're congruent. I'm going to write that here. So OH parallel to AT does not mean OH is congruent to AT. So what do we have here? In terms of parts, we have HW is congruent to WT. So we just have one part congruent to one part. We have things crossing, so we have our vertical angles. And we know that vertical angles are always congruent. And I need to remind you of something. So if you have two parallel lines, okay, so I'm going to mark them. So these two are parallel, cut by a transversal. Then they form angles, and certain angles are congruent. And one that we're going to use here are these two angles. So we'll call it angle 1 and angle 2. And we can say that angle 1 is congruent to angle 2 in this case. So you have to have parallel cut by a transversal, and we call those alternate interior angles. And in that case, they are congruent. You have to have parallel in order to say that. Okay, and we have that here. We can think of this angle O congruent to angle A because they would be alternate interior angles. So if if you pictured these as parallel lines cut by your transversal here, right? Also, you could angle H would be congruent to angle T. Those would also be alternate interior angles. So we got a lot of information now. We could say triangle OWH is congruent to triangle sorry, let me mark. I already used one arc with W, so I have to use 3 arcs here. So OWH goes with AWT. And Y, what shortcut can we use? Can we use angle, angle, angle? Well, it's true that we have angle, 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 but angle, angle, angle is not a shortcut we can use. What else? What could we use? We have a side, and we can do angle, side, angle, because we have a side between two angles that we know. Or we could say by angle, angle, side. So there's two possibilities. You don't need both. You just need to use one that works, a shortcut that works. And remember, angle, angle, angle does not work. Okay. The next page, I want you to finish up for homework. I'm going to do one of them with you, though. It could be a little challenging. But these work just like the previous page. Let's look at the very last one. You have some overlap here, right? And there's a lot of different triangles in here too. So you got to look at what's given to you. So we have that right angle, and so I'm going to draw the two triangles that have the right angle. So we have, and I'll separate them. We got M, F, R. That has that right angle here, and this marking here. And then we have, so I'm just separating them. M, R, A. So they're both right triangles, and they both have an angle congruent to an angle. They both have a side congruent to a side, but looks like we're still missing a piece, right? But before I separated them, they were sharing a side. MR is congruent to itself. And so that's the tricky part, to see that MR is congruent to itself. It makes sense once you see it, but at first it may be hard to see that. So once you get that, we could say that triangle MFR is congruent to triangle, order matters, start with the right angle, R, then M, and then A. By what? Do I use hypotenuse leg here because we have right triangles? No, because we don't have a hypotenuse congruent to hypotenuse. Remember, hypotenuse is your longest side, and we don't know that the two hypotenuses are congruent to each other. It doesn't tell us. Hypotenuse is always across from the 90-degree angle. So what do we have here? Well, we have side, angle, side. So that's it for this lesson here. Any problem I did not do, you're going to have to complete, and then you're going to submit all 4 pages to Gradescope.